Hello, welcome back to Math 110. We're going to do lesson 1.8 today. Lesson 1.8 is basically doing some diagrams, looking at diagrams, reading them, and then we're going to focus on some Venn diagrams, which is a special type of diagram. So here they're telling you skill 1, read numbers from a diagram. This is basically a building with classrooms in it, and it basically gives you some other information. Here's room 301. They have 28 students in there. 302 has 24 students. And a number one of these are listed. Some have room numbers, and some don't give you the number of students. And then they're just asked for different relationships among these. So here, just in general, there were 24 students in room 302 that we talked about. There were 4 more students in room 305 than were in 304, so we can do relationships. Here's 305, 304, 4 more here than here, 40 minus the 36. So 4 more, 4 less in 34 and room 304. So you can do different types of relationships and use your math background to understand those relationships. How many students were in room 309? 309 had 19 students over there. How did that number of students in room 305 compare to the combined number in rooms 301 and 302? So in 301 and 302, we had 1252. And how did that compare in 305? Well, in here there were 12 more students. Here there were 12 less students in 305 than the combined number in 301 and 302. So here, take a look at this. Pause and maybe go back and work those relationships. Here's what we're going to finish up talking about. Here's our new learning objectives. Analyze how your personality and type affects how you interact with others. We're just going to spend a few minutes on these. Here's the big thing. I want to create and interpret Venn diagrams. These are used all over the place. And then describe sets using appropriate terminology. So here is some basic personality assessment types, and we're just going to use these because they can look at things where we have a couple of students. We can compare things that they have similar and things that they don't have in common. So in preparation for this class, you should take an online personality assessment. If you get a chance, please do so. The result is a 4-letter code that describes your specific personality type. The code is made up of a combination of 8 letters and 4 pairs. So we would give by learning what each letter represents. So the first pair is either E or an I. You're either an extrovert or an introvert. And you can spend a few minutes reading through this to learn about that in your text. Second pair is either sensing or intuition, S or N. Third pair is you're either thinking or feeling. And then the fourth pair is either a J or P. You're either judging or perceiving. Again, spend a few minutes on this. I'm just going to use these letter codes and then put them in terms of a Venn diagram so we can see things that if 2 people took this personality assessment, how they look at things in common and how are they different. So here is a Venn diagram. We use a new type of graph known as a Venn diagram to see how your personality type compares to others, and later you'll reflect on how this might affect working with others in groups, things that you have in common, the way that you work and interact with others. But basically we're going to come up with a couple of students here, Patrick and Arlene, and here is their assessment type, ENFP. And Arlene was E, S, F, and J. And this thing is is the Venn diagram that we're going to focus on. This is the big thing. A Venn diagram is basically, here is a block that considers everybody in what they call a universal set. This is everything that we are thinking of in common. Here is one set, Patrick, and that we can list things. And here's Arlene. Here's things that we can list in terms of Arlene. Okay. So what we're going to do is just basically, here's the things that Patrick has that Arlene doesn't. Okay, over here, this little shaded region in common, those are the things that are in common. So we're going to list these type of assessment personality types that are common to both in here, unique to Arlene over here, unique to Patrick over here, and this would be things that maybe neither one of them, you know, if that was there, but it wouldn't be here because we're only considering these four things. Okay, so let's see how that looks in a Venn diagram. So here's Patrick, here's the listing again. So we see if we go through these by pairs, here was an E and an E. Both Patrick and Arlene was type E for that pair, so we're going to list it here in the common. Patrick was a type N, Arlene was type S, so we list those over to Arlene only, Patrick only. F and Fs are in common, and then the P for Patrick, and then over here J is in Arlene. Okay. So that's basically a Venn diagram so that you can kind of look and see which one is a only type situation for this set, only situation for this set, and things that things have in common. Okay, and we'll talk about that in a few more minutes. Venn diagrams are used all the time in studying sets. A set is any collection of objects. Like the letters that make up your personality type, we prefer to work with sets that are well defined. A set is well defined if you can objectively determine, based on facts, opinions, rules, something that we can say definitely this meets these criteria, is whether an object does or does not belong in a set. So here's just a couple of examples. Which of the following is well defined? Why? The set of all good shows available to binge watch on Netflix. Well, good shows is really a not well-defined criteria. One person may consider it a good show, another person may not. So we would not be able to build a set, a well-defined set based on that criteria. Okay? Simply an opinion, no clear criteria. So what about B, the set of shows with all seasons available on Netflix? I would consider that a well-defined because we know we can go up to Netflix. We can find shows that only have the all seasons available. So if it only has one season and they were recorded two, that wouldn't be in our set. It has to be all the shows and all the seasons. Okay? So that we could build up a set and then list them, and we're going to talk about listing in just a second. So each object in a set is called an element or a member of a set. And one method of describing a set is called the roster method. Just like a roster that you're going to do a class roster where I call the students' names to make sure they're there for attendance. The roster method, we take elements and list between braces with commons between the elements. The order in which we list elements isn't important if it's not well ordered, okay, an ordered pair. This, the order in which they list elements isn't important. 2, 5, and 7 and 5, 2, or 7 are the same set. It's just a list with the numbers 2, 5, and 7. Okay. Be 2 apples, 5 apples, and 7 apples. Often we will name sets by using a capital letter. We might name the set of objects in the left circle in the diagram where we did in question 2 using the letter A. So the letter, this was E, N, F, and P. That would be a set A. Curly brace, all the elements, these are the elements, E, N, F, and P, and then we close curly brace to say our set is ended. So the universal set is the set of all objects under consideration in a given situation. Not all objects in the universe, which would be silly. I may list a set of colors, and that would be the set of colors that I fully list would be the universal set, and then I could ask person A which colors they like, person B which colors they like, and I would call that set A and set B. But within that universal set is all the colors. Okay. So here, in the case of the letters from the personality test, the universal set could be written as, it could be an E, I, S, N, T, F, J, and P. Some things may not have showed up, so if we went back, those things listed outside of those two circles, but within that square block would be part of the universal set that was not included in either one of those. Okay. The complement of a set is the set of all objects from the universal set that are not in the set that we have named. So we'd have A, here's a set A that we have listed. Okay, let's say up here, the complement would be A prime, and that would be the others that are not in there. So I would list I is not in there, so I should be here. S is not in A, so it should be in the complement. N is there, so it's not going to be in the complement. T would be in the complement. F is in the set A, so it's not going to be in the complement. J would be in the complement. And P is in the set, so it's not going to be in the complement. So this is the A prime based on the universal set, and here's the listing of A. So it can't be, no element can be in the set A and its complement at the same time. So here is a more general version of a Venn diagram. And there are 4 distinct regions in a Venn diagram using this illustration, 2 sets A and B. We'll want to number the regions for reference, so they use Roman numerals. So everything won't be confusing, they'll be well defined. And then this is how we're going to do. Write the appropriate description next to each region. Pick your answer from the following list. Region 1 represents everything in A, but not in B. Okay? Because 1 and 2 is everything in A, but it's also got some things in B. So here 2 is common to A and B. This is the things in A, not in B. Region 2 represents those things that are in common between the set A and the set B. So we look at the list of the roster for A, the roster for B, things that are in common we put in this little region here to represent they're both in there. So the elements in both sets, A and B. Region 3, the things that belong to B but are not in A. Region 4 represents the universal set that are neither in set A nor in set B. Okay, so those are the other things that have not been inside a set. This set of elements that are in sets both A and B, this little region, this region 2, is called the intersection. So if you hear anybody say, I want to move myself back up just for a second, hold on. So if you hear of the intersection of 2 sets of A and B, that's that region 2, and in words, it's the things that are included in A and in B. So you can think of that as A and B, but it's really A intersecting B. And the intersection is what's in A and in B. The set of elements that are in at least one of sets A and B is called the union of A and B. So anything here between 1 and 2 or 2 and 3 could be in the union of A and B. So A union B is this uppercase U, looks like uppercase U, and this red is the things that in A or the things are in B. So 1, 2, or 3, 2 just happens to be in both of them, but anything in A or anything in B is in A union B. Okay. I wanted to take a second though and look at some other things. I'm going to hold out. I'm going to go to this little diagram that I've constructed. And I wanted to do another version just to show you how you could do other sets. Here there's nothing in common. If you have nothing in common, we could add up these things pretty quick. 100 like neither. So 100, these people are neither like red or like blue. So these are some colors, and they picked out. So I asked, do you like red, do you like blue, or do you like neither? So this would be everything in here is the universal set. Outside is the things that's not inside A, the set A, and here's set B. So that would be the thing. And nobody liked red or blue. Okay. So we could easily calculate this up. How many people took this survey? 100, 50, 200 total, because there was nothing in common between the two. And I wanted to point out another point. When you're counting, you have to be somewhat careful. So I'm going to go back and let me just start over and build another situation. going to start out with everything in my universal set. This is the universal set. So let me put this here. And I'm going to try to get this in common. Let's put that there. Maybe I can stretch this down here. Just like that. There you go. So this is going to be, let's say if we call this, let me get my pen here. Click. Yeah, that's what I want. Thank you. So this is going to be my set A. This is going to be my set B. Now let's say A likes red, B likes blue. This is blue only area. Blue only. And this is A only. This is the common, and this is outside. So let's say if I had these numbers. Let's go 100 neither. And if I said A has, let's say, I'm going to go up here and put some criteria. We have 200 people surveyed. Okay. 100 here. Let's say 75 like A and 75 like B. I want to fill in these areas, these regions, 1, 2, 3. Remember that previous one? Before I just said, okay, this is easy because if we knew this, we could put 75 here, 75 here. But notice if I did 75 and 75, that's going to be 150. And then I've got here, that's 250. So if you are asked to work on this, if I'm given some criteria like this, what you need to do is recognize that there's some things in common. I just can't add up 175, 75. I get too big. So what I like to do is say, how much did I go over? I know 100 is distinct. I may have some over. So I should have 200. I've got 100 and then the 150. So I got 250. I went 50 over, which means I counted 50 people twice. Okay, and then I work on there. So 75 total B, 50's in common, 25's outside. 75 everybody, 50, 25 in common. I'm at 25 outside, that's distinct. And then you can basically add up and see if this works. These are A only, 25, B only 25, so that's 50. 50 in common plus the 100, that gives you the 200 people. So I'm hoping that'll kind of help do these counting arguments as you go along. We'll see this from time to time in the course. Okay. So I hope everyone found this instructive. We'll go on to the next lesson next time. See you then. Have a good day.